Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Consecutive Arrow Sums by Will Power. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We also have arrows plus rule, where numbers on arrows sum to the number in the arrow's pills, and pills are read from top to bottom. Also, pills that are next to one another are unique consecutive numbers. So again, this is basically the top digit is the tens digit and the bottom digit is the ones digit. So for example, you could have something like 6, 8, 4, and 7 could add up to 25, right? This is the tens digit, this is the ones digit. 6, 4, and 8, 7 add up to 25, which would satisfy this pill. So that's an example of how these arrow pills work. And pills that are next to one another are unique consecutive numbers. So this must be consecutive with this digit. So this would have to be 24 in this case, if that were the case. And those are examples of how the arrows work. And in addition, we have this constraint that these must be consecutive. So imagine sort of like a white dot that was between all of these cells. We have crop key pairs where numbers with a white dot between them are consecutive and numbers with a black dot between them are in a ratio of 2 to 1. Not all possible dots are necessarily shown. So for example, if this were say a 6, this would have to be 5 or 7 to make sure that these digits are consecutive. If this were say a 2, this would have to be 1 or 4 to maintain the 1 to 2 ratio that's between them. And those are examples of how crop key pairs work. And finally, we have killer cages, where numbers in cages sum to the number in the top left corner of the cage. So, for example, if this were, say, a 3, this would have to be 7, because these two digits must add up to 10, because they are in a cage, which has 10 in the upper left-hand corner. And those are the only digits there, so that's why this would be 3 and 7. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, two digits that are, well, two digits always can only add up to a one-digit number or a two-digit number, with a two-digit number with the ones being in the ones place, or the tens place. And this is a two-digit number, so these all must be, this must be 1, this must be 1, and that must be 1. And they're all consecutive. Well, since this can't be 1, this has to be 20-something, because 4 unique digits can only add up to at most 30, but that would mean a 0 in the ones digit, which is not allowed, because we can't, every digit must be from 1 through 9, not 0 through 9. So these must all be 2s then. So these are all 2s, and these must be consecutive. Well, these two must be consecutive, and these two. This is consecutive. This sum is consecutive with this sum and this sum. This is in, here we have 4 cells, 2 of which are in 1 to 2 ratios with 2 other cells. Well, the only digits that can be in a 1 to 2 ratio with 2 other cells are 2 and 4. So these necessarily must be a 2-4 pair. This digit then must be in a 1 to 2 ratio with that cell, and it cannot be 2 or 4 because of the 2-4 pair in the box. So this is 1 or 8. This cannot be 1 here. So this must be 8 here. This is 4. That's 2. That's 1. To be in a 1 to 2 ratio. So this is 8 plus something. It cannot be 11. It could be 12 here. But if it's 12, that would require 4 to be there, which is not possible. So then what are the other possibilities? 13 with 5 and 8, that works. 14 obviously doesn't work with 6 and 8 because of 4 in the column. 15 with 7 and 8. 16 does not work because it would have to be 8 and 8. But 17 could work if this is a 9. So if this is 5, 7, 9... If this is 3 and 5, so 13, to be consecutive with 13 would have to be either 14 or 12, and 4 would not be consecutive with 5, or sorry, 2 would not be consecutive with 5, so it would have to be 4. So either this is 3, 5, if this is 3, this is 5 and 4, 14. If this is 5, this would have to be 7 and 6, and if this is 7, this can never be 18. So therefore, this can't be 7 and 9 here, because this can never be 18 this way for the sum of 2 unique digits. So either this is 14, in which case this is 5, 9, or 6, 8, and 8 cannot be here, so therefore 6 couldn't be there, or it's 16, which forces this to be 7 and 9. Okay. This is in a 1 to 2 ratio, which does not include 2, so it's either 3, 6, or 4, 8 there. Okay. This cannot contain a 2 to add up to 8, so it's either 1, 7 or 3, 5 there. So we're guaranteed one of these digits is 1 or 3. Can you ever have a 1 there, right? So 1 with 3 other unique digits. I guess that could work. Never mind. I was thinking that would be forcing something, but that's not. Okay. So this has to be consecutive. This pill has to be consecutive with this. So it cannot be 12. So this is also 14 or 16 here. Which means we're guaranteed one of these is 5. If this is 13, this is 5. If this is 15, obviously this is 5. So this cannot be 5 and 9 adding up to 14. It's 6 and 8. Otherwise, it's 7 and 9 adding up to 16. Okay. Where is 2? Well, we have 4 ones. 2 has to be one of these 2 digits in this left central box because it cannot be here and it cannot be adding up to these sums. Two cannot be here or here. Remaining digits, do I want to do it that way? This can't be 2 and 9 because of 2 in the row. 2 actually has to be, cannot be here because of 2 having to be one of these digits. 2 can't be here, 2 can't be here or here because of 2's in the rows. So 2 has to be there. Remaining digits in column. Well, let's not do that. Let's do remaining digits in this lower left-hand box. It's 3, 5, 6, 7, 9. Okay. And actually, it's the same here. This is 3, 5, 6, 7, 9. So we are guaranteed, though, if this is 14, this has to be 6 and 8, because actually this is guaranteed to be 5 here. So it's 13 and 5 or 15 and 7. So this cannot be 5 remaining in column 3, which means this cannot be 5, 9. So if it's 14, this is 6, 8. If it's 16, it's 7, 9. Either way, there's a 6 in one of these 3 cells, which eliminates 6 in the rest of the column. To add, this cannot be 9 because 9 and 2 add up to 11. 3 would require 8 to be here. 6 would require 5 to be here. 7 would require 4 to be there. Okay. Um. Um. Where is 2 in this lower right-hand box? Can't be here or here because 2 is in the column. Can't be here because of 2 in the row, so 2 has to be one of these two. No 2 here or here. 2 cannot be here. 2 cannot be here in the central box because of 2 is in the rows and the columns, so 2 has to be here. Which means 2 cannot be here or here in this lower central box. Where is 2? It has to be here. So this is 2, which eliminates 2 here. That forces this to be a 2. Where is 4 then in row 7? It has to be one of these two digits because it cannot be here because of 4 in the box. Can't be here because of adding up to 8 with 2 digits. If this were 15, that would force this to be 7. So this could not be 7, 9 anymore. It would have to be 6, 8, and 4. That doesn't help us much. Okay. 1 in row 6 has to be one of those 3 digits because it can't be here because of the ones in the boxes. This must be consecutive with this. Cannot be 2. If it's 3 here, therefore this must be 4. If this is 4 here, this could be 3 or 5. That's fine. If it's 6 here, that's 5 or 7. If it's 8 here, this is 7 or 9. Um... what else do we have? Possibilities. This is 1 and this is 9. 3, 7 in either spot. 4 here and 6 there. That's not that restrictive. Uh, um, to be consecutive with this, again, 3 can be 4 here. 4 could be 3 here. 5 could be 4 or 6. 7 could be 6 or 8. And 9 could be only 8. Hmm. Dang it. Okay. Um, hmm. If this is 3 and 8, that would mean this cannot be 6, 8. So this would have to be 16, which adds up with 7 and 9. But if this is 3, this is 15, and that would be 7, which would mean we have 2 7s in this box, which is not allowed. So this cannot be 3 and 8. If it's 4 and 7 here, this is 4, which makes this 16, so this would be 7 and 9. Oh, that's interesting. Hmm. So if this is 4, this is 7. Therefore, this would have to be 13 and 5 here. This would be 16, 7, and 9. So that would be 3, 5 as a pair. So I think one of these has to be a 4 then, right? If this is 14, obviously there's a 4 here. If this is not 14, it's 16, which forces this to be 7, 9 as a pair, which eliminates 7, 9 in the rest of the column. Therefore, this becomes 3, 5 as a pair, which would force 4 to be there. So one of these is guaranteed to be 4. So if this is 16, 7, 9, 3, 5, 3, 5, this would be 4, that would be 8. This is 14, this is 5 and 6. So 14, 6, and 8 here. And the rest would be odd. So it could be 3, 5, 7, or 9. Cannot be 7 here, because again, if this is 5, well, no, that's 5, right? 14 makes that 5, never mind. So this couldn't be 5 then. This would have to be either 8, with this being 7, 9, or it could be an odd digit, because this would be 14, 6, and 8 here. Please. This is getting a little hairy. I don't know. I don't know if these have to be. Yeah. Do these pills have to be unique? Because it says otherwise. I don't understand why you would say also pills that are next to one another are unique consecutive numbers. You could just say consecutive numbers if they're not unique, right? So therefore, these would have to be different than this necessarily, right? So it would have to be like 4, 5, and 6. Well, if this is 5, this would have to be greater. So I think because of the unique constraint, then that's saying that these have to be unique here as a pair, consecutive numbers, and these must be unique. You can't have 15 with both 16 and 16 here, right? I think that's how I would interpret that. Otherwise, unique is superfluous if it's not meaning that, right? You could just say also pills that are next to one another are consecutive numbers. So I think that actually requires that this to be 15 and 17, which makes this 6 and 5. Therefore, this is 16, which makes this a 7, 9 pair. Which means this cannot be 1, 9, or 3, 7. Therefore, it must be 4 and 6. So we have 4 and 6 there. This cannot be, this has to then be not 7 and 9. It's 14 with 6 and 8. This can't be 6 because of 6 in the row, so that's 8 and 6. So no more 8 here. This is 5, which eliminates 5 in the rest of the column. This can't be 6 or 7. This can't be 6 or 7. We have a 3, 7, 9 triplet in this lower left-hand box, which eliminates 3, 7, 9 in the rest of the box. So this is 5, 6, 5, 6. Remaining digits here are 2, 3, and 9. In this left central box, obviously this can't be 2. Remaining digits in column. This is guaranteed 7 here, so this cannot be 7 here. So this must be 4, 7, and 8 remaining in column 1. Yeah, I don't know of another way you could actually go about solving this, because I think that would have led... There's not enough restrictions otherwise. 6 eliminates 3, 6 as a pair here. So this is 4 and 8. 4, if this goes to 3, then this would have to be 22, which doesn't work, because these must be unique consecutive numbers. So it could be 4 going up to 5, and then 6. 8 cannot go to 9 because that would go to 8. So this would be 46 to 57 down to... So 4, 5, and 6 there, or 8, 7, and 6 there, because they must be unique. So that's 6. 26 there. 4, 8 as a pair. That eliminates 4 and 8 in the rest of the row. So the remaining digits then are 2, 3, 7, 9. This can't be 2. This can't be 2. If this is 28, this would be 4. And this must add up to 27. Could that work? I think so. Remaining digits in... Well, how many 6s do we have? 6 can't be here or here. In row 4, 6 can't be here because of 6 in the boxes, so 6 has to be here. Therefore, this can't be 2, 8, cannot be 4, 6. It's 1, 9, and 3, 7 there. Remaining digits in this right central box are 1, 3, 5, 7, 9. 7 obviously can't be any of these. If this is 20... If this is, again, 4, 28, that's 27. Where is 6 in row 7? Cannot be here because of the 8 cage here, and this is a 2. Can't be here because of 6 in the box. Can't be here because of 6 in the column, so 6 has to be here. So this is 6, which makes that 5. That means 5 cannot appear. What are the remaining digits in this lower central box? 1, 3, 5, 8. 5 cannot be either of these. This can't be 1 because of 1 in the row, and this can't be 8 because of 8 in the row. So 26 can never have a 1, because if you had a 1, 1, 7, 8, and 9 only add up to 25 at most. So this has to be 3 or 5. That means this can't be 3, 5 as a pair, because that would eliminate all possibilities for this cell. So we're guaranteed one of these has to be 1. Which means this must be 25 and 24, because 27 and 28 cannot have 4 unique digits if one of them is a 1. And we know one of them is a 1 because this is a 1-7 pair. That 1-7 pair eliminates 7 here, so it says 9 and 7. 9 and 7 eliminate 9 and 7 here, so it's 3, which makes this 9, which makes that 7. That makes that 9 and that 3. This 3 eliminates 3 here, so it's 5. Which eliminates 5 in the rest of the box. So this is 25 and 24, which makes this 8. Then eliminates 5 from the rest of the box. So we have a 1, 3, 9 triplet, which eliminates 1, 3, 9 in the rest of the box. This can't be 3 or 9. It's 7, which eliminates 3 and 7 as a possibility for this 10 cage. That 1, 9 pair eliminates 1 and 9 in the rest of the column, so this is 3. Which eliminates 3 here and 3 here. So to add, one of these is guaranteed to be 1. This is guaranteed to have a 1. So 1, 7, 9, 1, 7, 8, 9 adds up to 25. 1, 6, 8, 9 adds up to 24. So this can't be 7. This is 1, which makes this 7. 1 eliminates 1 here, so it's 9. That makes that 1. This is 3, 9, which eliminates 3 and 9 here, so that's 2, which means this can't be 2. These can't be 7 because of 7 in the row. This 3, 9 pair eliminates 3 and 9 in the rest of the row, so this is a 2. This has to be 1, 7, 8, and 9 to add up to 25. This is 1, 6, 8, and 9 to add up to 24. The 6 eliminates 6 in the rest of the row, so this is 8. This is 6. 8 eliminates 8 in the row, so it's 3, which eliminates 3 here, here, and here. So this is 9. This is 3, which makes that 9. 5 and 9 already add up to 14. 26 minus 14 is 12, so the remaining 2 digits must add up to 12. And cannot be 5, 7, or 3, 9, because those are already taken, so this must be 4 and 8. This can't be 8 because of 8 in the row, so this is 4, which makes that 8. That makes this 5. 8 eliminates 8 here, so it's 1 and 8. 9 here eliminates 9 here, so this is 1 and 9. And the rest we're probably doing from Sudoku. This is 3, 7 as a pair. 3, 7 can't be here because of 7 in the column, so that's 3 and 7 there. The last remaining digit in row 8 is a 5. In row 9, it has to be 3 and 4. This can't be 3 because of 3 in the column, so this is 4 and 3. The last remaining digit in column 9 is an 8. In column 7, it has to be a... Sorry, in column 6, it has to be a 7. In column 7, it's 4 and 6, and this can't be 6 because of 6 in the row, so that's 4, that's 6. No 4 here, no 8 here, no 7 here. Remaining digits in column 8 are 3, 5, 7. This can't be 7 because of 7 in the row. No 5, no 3 there. In column 4, we have 4, 5, and 8. This can't be 4, 5 because of 4, 5 in the row, so this is 8. This 8 eliminates 8 here, so it's 7, which eliminates 7 here, so it's 3, which makes this 5, which makes that 7. 7 eliminates 7 here, so it's 4, which makes that 8. Again, this is 4 and 5 as a pair. 4 can't be here because of 4 in the row, so that's 5. This is 4, that makes this 3, 1, and 9. And that's a solution. Okay, yeah, I wish that this had been more, I guess, highlighted, because I wasn't sure about this part. But once I started solving it, I realized that it had... I don't think there was a solution if you had the ability for these to be essentially potentially the same. So, anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.